All right, here we go. Okay, so today we are going to talk about the parts of a wave. Last week, we learned that there are two main types of waves, longitudinal and transverse. I know you guys were thinking about that all weekend because it's so cool. But today, we're going to look at the parts of a wave because right here on the screen, it says to measure how much energy a wave is carrying, we need to know the names of the parts of the wave. So if we're going to measure things like wavelength, amplitude, frequency, we got to know what those things are, right? So everyone will need a blank piece of paper. It doesn't matter if it's lined or unlined, just any sheet of paper will do, okay? So if you don't have paper, I need you to get it real quick. It could be out of your printer, it could be out of a notebook, it could even be scrap paper. You're not going to turn it in, but you're going to have it for the quiz on Thursday. Okay, so you're going to draw this diagram as big as your paper, okay? And I want to show you one little hint that you could do. If you fold your paper hot dog way, yep, I said hot dog way, the long way, okay? If you fold it down and then you open it back up, it will give you a nice middle line, okay? Because I do want you to include the dotted line across the middle. So if you fold your paper in half hot dog way, it'll automatically give you a line. But nice and big. Whee! That was me drawing. You're gonna draw this wave, okay? Doesn't have to be perfect, but it does need to have the up, down, up, down, up, down. Okay. So everybody should have that drawn in the next 1 minute. Okay, go ahead. I don't know if you can see mine. It's not very beautiful, but that's okay. We are gonna label some parts of a wave, and then as soon as we're done labeling, we're gonna do a labeling group challenge. So pay attention. If you want that extra credit, you need to make sure that you label well. Okay, the first thing, if you just saw the green arrow show up on my screen, that middle line is what we use to compare the height of a wave to, and we call that rest position. So on my green arrow, it just showed up rest position. On your diagram, you can include the arrow if you want, but along that dotted line, go ahead and write rest position. Okay, so when you're resting, you're sitting still, right? And rest position is that line across the middle that we're going to use to compare the size and the movement of the wave. So if you didn't already do so, please label that middle line rest position. Good job. Okay. The next thing we're going to measure is this blue arrow. Notice it does not go from the top all the way to the bottom of the wave. It only goes from the top to the middle or even the bottom to the middle, okay? But from the peak or the crest of the wave to the middle, that has a name and we call it amplitude, okay? If you can't see my tiny letters inside the arrow, I also put it above. But on your diagram, go ahead and draw an arrow from the top to the middle or the bottom to the middle and label that amplitude, A-M-P-L-I-T-U-D-E, okay? So amplitude, we're gonna see in a little bit, shows how much energy that wave is carrying. So do you think that a large amplitude or a small amplitude is gonna carry more energy? Somebody answer me in the chat and tell me what group you're in. Do you think a large amplitude or a small amplitude is carrying more energy? What do you guys think? Okay, good job, Gracie. What group are you in? Group 6. Okay, so group 6 gets a point for that. A large wave, right? That makes sense. Like picture a big ocean wave. A large wave, a large amplitude is a higher energy wave. Good job. Okay, so we have labeled rest position and amplitude. The next thing we're going to label is the high point and the low point. And those names, are the crest and the trough. Okay, so crest and trough, the high point of the wave, okay, up at the peak or the top point, that's called the crest. So if you think about like a mountain, okay, the crest of the mountain or crest of a big ocean wave, that's the peak or the top. And then trough, I always think of like an animal trough because it's kind of that shape, but that's the lowest point of the wave. So on your diagram, you should have labeled crest and trough, okay? So Levi, thank you for joining us. We are just doing some quick notes. These will be posted in Schoology later, but right now I'm having everybody just do it on a piece of paper, okay? Old school. Remember before computers when we used paper? Okay. So everybody should have 4 things labeled: rest position, amplitude, crest, and trough. There's one more thing we're gonna label, okay? So you might remember in our energy unit, Mr. Gallant talked about something called wavelength, okay? The wavelength of a wave is from crest to crest, or you could also measure from trough to trough, but it's the distance between waves. The length of a wave is wavelength, right? So on your diagram, on mine, I'm doing it from one crest to the other, okay? We're gonna call that wavelength. So wavelength, the length of the wave, is the distance between waves. Okay, I have another question for you, and I need somebody to answer in the chat and tell me what group you're in, okay? When we're talking about wavelength, the distance between waves, do you think that a high energy wave, a wave carrying a lot of energy, is it gonna have a long wavelength or a short wavelength? Okay, so the answer could be long or short. So there's a high, ooh, nice, Elliot, and then Jaden, and then Gracie. Okay, so Elliot is in group 4, and Jaden is in group 1. Okay, Gracie's group, I'm gonna give you another point. All 3 of you got it. It is a short wavelength. So if you think about a wave being like hyperactive, lots of waves in a short amount, the distance between those waves would be small. So a short wavelength is a high energy wave. Good. So everybody at this point should have this much labeling done. Is everybody there? Yes? No? Maybe so? No? Okay. Well, I'm going to give you 1 minute to go ahead and catch up, but don't worry because this is also going to be in Schoology. So I'll pause for just a minute, but your diagram should look like what's on the screen. Okay. Diagram. It will be posted in Schoology after class, but also you could start it now just on your own sheet of paper. Okay, so you're going to get a piece of paper, you're going to draw this wave, and then we labeled these things: rest position, amplitude, crest, trough, and wavelength. Okay, 1 more minute now in class, and then if you don't finish, it'll be in Schoology.
I'm done, by the way.
Alrighty, we do have 2 other things that we're gonna write, and for me, I'm gonna write it on the back of the page that I did the wave, okay, just because I'm kind of out of room. You can do it on the front or the back, but after this, I have 2 things I want you to write, okay? I'm going to go ahead and move forward. So, like I said, flip your paper over to the back for just 2 quick notes that we're going to write. Oh, actually, I think it's, you'll see. Okay. So, you need to copy down what is in red. So, when we look at a wave, besides the parts of a wave, there's a couple other words we need to know to be able to label a wave. The first one is period or cycle. So if you look up here at my diagram, it says that the frequency of this wave is 2 cycles per second. So frequency and cycle, what do those mean? Okay, here's what you need to write. Okay, the period or the cycle of the wave is a full wave from one given point on a wave to that point on the next wave. So when it goes all the way up and all the way down and then back to rest position, we call that a cycle or the period of the wave. So everybody needs to write that down. You don't have to write every single word, but enough that you would get it right on a short little quiz. Okay, it is the full wave. So all the way up and all the way down. If you're a visual person, you could even draw that. Okay, like all the way up, all the way down. That is the period or the cycle is one full cycle of the wave, all the way up, all the way down. And then frequency is how many waves per second, okay, that pass a certain point. So if we say that this is 1 second, okay, then there were 2 waves in 1 second. Okay, so I'm gonna leave this up here for just another minute. I wanna leave us about 5 minutes for the group challenge. So everybody go ahead and write down that frequency is waves per second. I just wrote the word wave / seconds because that's how I'm gonna remember that. But go ahead and write something down. How many waves there are per second. Okay, this shows 2 waves per second, but for example, a lot of sound waves are like 500 waves per second. Okay, and we're gonna learn that when we talk about pitch, like high pitch sound, low pitch sound. That's how many vibrations per second. And we have all these waves. Okay, so period is the full wave, and frequency is how many waves per second. Okay, the very last thing that we're gonna do is right here, we're gonna write about high frequency and low frequency. So a high frequency wave, that word frequent means like how often or how much something is happening. So a high frequency wave is gonna have a short wavelength. There's very little distance between the waves. And a low frequency wave is gonna have a long wavelength, okay? So I was gonna show us this little interactive. I don't know if we'll have time to do it today. We might need to do it tomorrow because I wanna do the group challenge. But high frequency is a short wavelength, low frequency is a long wavelength. And because of that, we say that frequency and wavelength have an inverse relationship. Inverse means opposite. So if it's high frequency, it's short wavelength. If it's low frequency, it's long wavelength. So I'm gonna be quiet for a minute and have you guys write those little things in. diagram handy because we are about to do the group challenge with it. But one more time, high frequency equals short wavelength, low frequency equals long wavelength, which makes sense if you think about it. The waves that are close together are going to have a short wavelength. The ones that are more spread out are going to have a much longer wavelength. Okay, I'm going to stop recording myself.